So, notes to this page, I have to record. I hope it's going. I better turn my headset on. Yes, I think I'm in business. Just going to make sure here. Yep, I've got a green light. All right, so we're going to start off as usual. So let's go take a look at this guy. The definite integral means we have limits, which we've done. We've just never combined it with u sub. So section 4.5, you've got about 70% of it in your brain already. You should be very comfortable with who u is, correct? Almost always the inside function. Did I say always, though? Let me give you a classic case of u sub. That's u sub. That kid's butcher. And I gotta think of it. Off to the side here. Don't write it down. Here's a classic case of u sub that gets wackadoodle answers because there's no function within a function. I said usually, right? It's actually when the derivative of one of them is the rest of the integrand. Who's u in that one that I wrote with the trick? Sine, right? What's du then? Cosine. Or you could do it the other way, but I like to not have negative. So I would say that this is really in my head. This is the integral of u du. Would you agree? What is that antiderivative? U squared over 2 plus Carl. And then back sub it in. This is what I tend to see with one like this. Kids that go, oh, the antiderivative of sine is negative cosine. The antiderivative of cosine is sine plus Carl. LaRue, that was easy. And I go minus 4. You're like, what? You made up your own rule. Do we have a product rule for integration? No. Do we have a quotient rule? No. So, you can only do two things. You can only do u sub or use your power rule. This could have been done both ways, by the way, because I could have foiled it out and everything, but I don't want to. I don't want to. All right, so we know to do that. We're going to u, right? We know to get the rest of the integrand in terms of u also. So we go, okay, I need to do du dx, so I get 2x when I take the derivative. That's what du dx is. So du is 2x dx. We know we need to ask ourselves a question. Do we have it? It being the rest of the integrand. And the answer is so close, and I taught you what to do already. According to our book, we've never discussed this at all. So that's what you kind of should be like, oh, I got this. What do I mean when I say, do we have it? And I said, almost. I'm telling you I need a fraction correction. And you know what it is, correct? I would replace that x dx with 1/2 du. So I've got u, and then I've got a half du. Here's the problem, though. These aren't limits for u. What are they limits for? Like if I were to graph it, where are these located? On the x-axis, they're limits for x. These are x equals 0 to x equals 2. If I'm going to do u sub, right, it all needs to be about u. The entire thing. So what you need to do is go right here and say when x is 0, oops, sorry, that says when x is 2, but we'll do that one. When x is 0, my u limit would actually be 0 squared plus 1. When x is 2 on the top here, what would I do in terms of u? I won't use a 2 because u isn't a 2. What would u be? 5. So you're going to do what's called a limit change. So let's go do that. It says now write everything. I want you to put that in a box. This is really important. Everything has to be in terms of u or everything has to be in terms of x. Do you see how it says it's not necessary to switch back? I'll talk about that. All right, so let's go rewrite that. We have u squared from this guy, right here. Then we had 1/2 du. Since we went to u, we need to do what's called a limit change. We're going to go from not 0 to 2, but from 1 up to 5. Agreed? I'm going to take this on out. Once you go all u, you need never go back for a definite integral. You can integrate it in terms of u. You could say, well, this is u cubed over 3, right? That's what it's always been. I still have the 1/2 out front. You with me so far? And I'm going to be going from 1 to 5. I don't need to go back to x as long as I change my limits. All right? So when I go and plug this 5 in, I'm going to pull the 1/6 out front just to get it out of there. Correct? I still do what we've always been doing this whole chapter. Top limit goes in. It's a limit for you, and I'm putting it in for you. Totally legal. I would do 5 cubed. It's 125 over 3. And again, I pulled the 1/6 out from these guys down here. Minus 1 cubed over 3. I'm going to leave that right there for now. What did I do? Oh, not the 3. Yep, I took the 3 out. Sorry. I put it out with the half. Sorry. It looked like this. Now let's suppose, Brad, that you're like, I don't like you. Like, I hope you do, but at this point I don't. But if you're like, I don't like that. We've been back substituting, and I like back substituting. This is what you would have done. Right when you got here, you would have done what we do when it's an indefinite integral. We take u and we put its x stuff back in. What's its x stuff? X squared plus 1. So Brad might say, I'm going to do 1/6. You could just watch in blue, don't write it. And he might say, I am going to back sub my x squared plus 1 in. I'd say, you go. Then you don't need to have changed your limits. You would go from where to where? Original, 0 to 2. Watch what's going to happen. At the end, you're going to do what we did at the beginning. You're going to say 2 squared plus 1 is what? 5, and you're going to cube it. You're going to get this anyway. And you're going to say what we did when we got the 1 here. It's whether you do it at the beginning or at the end, you have to do it anyway, right? If you say, now I'm going to put a 0 in, you're going to go 0 squared plus 1, I'm going to get a 1. You will still get the 1/6 of the 125 minus 1. So then the question becomes, which is better, and why are you teaching us both? I'll tell you it's 50-50. So you pick your favorite, right? If you like to back substitute and put the x ones back in, you go for it, you'll get the right answer. Here's the only problem if I don't teach you how to switch it. What College Board will do is they'll stop mid-shift. Every single multiple choice question has a U-sub question where they don't take it all the way on out. So what happens is they'll say, which of these expressions is equivalent to that one? You know what I mean? They stop right there, and they'll put like, well, this here you'll have 4 options. So you'll have to know, oh, where are the 1 and the 5 coming from? Oh, that's right. LaRue said if we're going to go to U, the limits have to be what? In terms of U. If I don't teach you that, you would all have picked this one. You would. If I didn't say you have to change the limits, don't you think you would have left them? So I have to teach you that we change limits. You're going to do it today. And then after that, Mike, it just depends. Like if you're at SPC kids, do you change your limits when you're doing U-sub? They'll say sometimes. They kind of know the trig ones tend to get nicer, like a little less messy if they work with it at the beginning. Or things like this one with roots in it tend to be a little less messy. But it's completely up to you. We're not going to do this one. We're going to go to exam. Again, I don't have to do all of this because of why. According to our book, you didn't even know U-sub yet. All right, so we should know how to start. So I looked at this one and I say, hey, example 3, you're a U-sub candidate. Why do I say that? Nothing else works. We only have 2 methods, right? Use almost always the inside function, and in this case, that's perfect. So we're going to today write u equals x squared plus 4. But we're going to stop today, and we're going to change our limits right now. I'm going to force you to do it for one assignment. And then after that, it's just if you know how to do it, you're totally fine if you want to go back to x. I actually like it, so I choose to do all of them. I like to do it. I like to just get it to you and be done. So when I put in a 0, right, I would be going from 4. Instead of my bottom being a 0, it'll be a 4. When I put in a root 3 and square it and add 4, what would I get? A 7. Yep. So when I write my new integral in terms of u, I'm going to change my limits, and I'll never go back to x. All right? Now, if Maddie, 2 weeks from now, gets one like this and says, if not happening for me, I'm going to keep those limits, then what's she going to have to do at the end? She's going to have to use the 0 to root 3, back substitute the x, and then I'll show that working. So, here you go. What's my du? Take this off of here now. What's du? And I ask myself that question we've always asked. You should be good with the U-sub. Is it what I need, or do I need to correct it? I correct it because this doesn't say 2x dx, it says x dx. It's a really good review right now. That's why I like splitting 4, 5 up like this. It's really good just to re-talk about this. All right, once I get here, I rewrite the entire thing in terms of u. Are you ready? So I go like this, right? I say that was a root of my u choice on the bottom. This guy is u. The rest of the integrand is 1/2. This guy right here, 1/2 du. So remember, I like to throw it off the backside and go like that. Some folks will put du over. Some even write u prime over. All right, there it is. What will I use as my limits? Because I'm going to u, I will go from 4 to 7. All right, so go ahead and write that. And then don't write what I'm going to do next. If Ashley mixes the two, okay, she goes to u, but doesn't change her limits, and writes this, and then write equals. But when she goes to plug them in, she changes them. You'll get the right answer. But what do you think they're going to call that? Linkage. Exactly. My limits, these are x limits for a u thing, so even if I change it later, I've got it linked in correctly. So if you are going to go back to x, here's my suggestion. Don't put any limits on it until the end, because then they can't mark it wrong. Okay? And I'd also not put any equals then either. I just let it roll. But I'm going to do it the proper way, because I think that's how it should be done. All right, so this is where College Board stop ship for a multiple choice. They'll say which one of these is correct. I bet most kids nationwide don't pick that. You get why? They're going to go, well, I know I at least need to have limits going from 0 to 2, so I'm not going to pick that one, right? This is the correct one for my u choice. Now I'm going to keep on going. What's the antiderivative of u to the negative 1/2? That should be smooth. What is it? 2u to the 1/2, correct? So I'm just going to write 2 root u. If that's rocky for you, that means you need to practice your fundamental theorem a little bit more. There was a 1/2 out front, and I'm keeping u, and my limits are for u. All right? My 2's cancel. How are we doing, Gil? You're with me? So my answer would be root 7 minus what? Root 4, which is 2. I'm going to put that in blue and in a box and tell you that's my absolute most favorite way of doing that one. I like, hey, do you change your limits when you're doing u sub, or do you go back to x and use x's?
It kind of depends.
What did I say BC kids would say? It depends, or did I say sometimes? It depends. If you feel like it, and if you think it's going to make it better, you do it. But again, let's pick on Tyler this time. She's like, I don't like it. Rude. Hate it. Then this is what you would do. You'd say, all right, right here, you'd say, I'm going to replace u with what it actually is. What is it? I don't remember. What is it? What was it? X squared plus 4. She goes, I'm going to back substitute, because that's what we did before when we did the indefinite kind. She can, but she has to make sure that for her limit, she uses the ones, correct? She has to use the original. Was it 0 to 2, correct? She has to go like this. No, it's 0 to root 3. What was it from? It was 0 to root 3? All right, 0 to root 3. And I'd say, Tyler, have at it. Now you need to do what we did at the beginning anyway to change the limits. Root 3 squared is 3 plus 4 is 7. 0 squared is 0 plus 4 is 4. I still get the same answer in red, so I'm going to ask it again. What's better? Blue, keep it in terms of u, or red, go back to x? And the answer is just what Sophie said. What'd she say? Depends. On this one, I'd say it's 6 of one, half dozen of the other. But I told you, usually when that happens, I only teach you one way. But I've given enough AP practice tests to know that College Board's onto that. And they want to make sure you've been taught to change limits. So they'll leave it undercooked, I call it. And like they'll have that one, and then they'll have one like this, where they keep the other limits. What was it originally? Did you say 0 to root 3? Then they'll have one maybe where the integrand's wrong and it has the right, they mix it up. All right, let's go to the next page and try a tricky one. We'll do 4 only, not 5. All right, so I start as usual. I ask myself, how do I integrate this? At this one, I only have 2 methods. I either use a power rule or I use u sub. Remember, sometimes power rule is disguised. For example, how in the world is this power rule? What could I do? Distribute, and I'm good. Okay? How about this? You remember how this guy's power rule even though it's a quotient, it makes a heart, we break it apart. So either goes power rule or it's U sub. You have no other methods in Calc 1. This is obviously U sub because it's tricky. So here's my U. Today, I'm going to force you to do it all in terms of U because that's my goal of the day. So I'm going to go here, I'm going to go here. I'm going to put in the bottom boundary and I'll still be at 0. When I put in the top boundary though, I'll be going to pi halves. So I just did a limit change. What does that mean? I'll never go back to x. It's all about U, right? Let's go do it. How about du? Oh, that's 2dx. I asked myself the same question. It's kind of boring today because my lesson's almost a carbon copy of 4 weeks ago, right? And do you remember me saying, is it what we need? And you say, almost, right? With a what? What do I need? Fraction correction. Yep. So I'll do that. I do 1/2 du shall replace the dx. This I used to make kids put this in a helper box and I'd take points off if they didn't. I kind of felt like that wasn't fair because honestly about half of you should be doing one like this in your head. But mistakes get made, so we're going to do it correctly. We're actually doing sine of u. The dx is 1/2 du. What are my limits going to be? 0 to pi over 2. And I'll never look back. Hannah, what do I mean when I say I'll never look back? And no back subbing. No going back to x because I changed my limits. So I'm going to do the antiderivative of sine correctly. It'd be negative cosine. So watch that you don't make a SIGN error. I don't back sub because I changed my limits. But again, if Tyler's like, hate that way, she puts the 2x back in. And she goes from where to where? 0 to pi fourths, but she doesn't put equals, and she's going to risk some linkage going on. So this is actually the best way to do it, which I like, but here we go. So I'll do cosine pi over 2. Top boundary falls in, minus bottom boundary, evaluated at 0. No need to go back to x. Now watch your unit circle. I'm going to ask you a question. If this is my test that I'm going to give you on finals day for chapter 4, and you got that, will you get full credit? No. My test, you have to do what you do if you're in college, which means you need, and if this is multiple choice on the AP exam, it'll be a cleaned up answer. So I want you to get used to simplifying. Be 100% sure what this is. What's cosine pi over 2? 0. We're getting better. What? It's louder, and I'm not hearing the random ones, whatever. What's cosine 0? 1. All right, so what's the answer to this definite integral? 1/2. Negative 1/2 times negative 1. If you math 9'd the original from the get-go, if this was calculator active, we wouldn't have done anything. It wouldn't have been calculated. But if it were, I'd math 9, that hit enter, and it'd say 0.5. All right? You get the hang of it? So what does this 1/2, Hogan? I already picked on you. Adam, I picked on you today. What does this 1/2 represent? I don't want you to lose track of what you're finding because you're no longer doing it where you can see it. It is. It's the area under that curve between those x limits. So it still is the area. So if I were to ask you, it's funny because I don't want to tell you. So give me an unfair advantage over the kids this morning. No, cross this one off. All right, we're going to go to the next one. I was going to say something about something on your test, and it won't be fair because I didn't say it to second or third hour. No, I'm not going to. This is good. Nope. Decided not to.
Give everybody an advantage.
No.
Yeah.
No.
Because then it's not an advantage.
Technically, you're posting, so we all have access to
No,
that.
not doing it. All right, let's go to example 7. Has nothing to do with U sub, right? It's actually the power rule, but I can't do it right now because absolute value doesn't have an antiderivative. It's an operation. It's kind of like addition. It tells you to add the two together. Absolute value is an operation that tells you to do something. What does it tell you to do? It says if whatever goes into those bars is positive, don't mess with it, right? It says whatever goes into those bars is negative, you better do what? Take the opposite, correct? So we have to get rid of these bars, how I taught you yesterday. For people who are absent, listen up. You guys who are here, how did I tell you? We got to get rid of those absolute value bars. What did I say you have to find? where we go less than 0. Yep. How do we find that always in this class? Sign line. This will require a sign line in your head, maybe for this one, because it's pretty straightforward, or off to the side, or maybe like Jade is like, I know what that graph looks like, Rude. Hello, it's an upside down parabola. It obviously hits at 1 and -1, goes like this. She might say, oh, well, I know from the graph that it's going to go negative, positive. Like, what you do, you, because you get no points for all that. I'm sign line blind, remember? So, however you make it, whatever. Now I need to take my sign line and let it help me get rid of these absolute value bars, because I can't integrate it until these guys are gone, but I still need to mathematically do what they do. So, I am negative over here, which means I'm going to have to pop it up and do this. Okay? What did I tell you yesterday you have to do in that little region then? It's kind of like you got -5, and I need to make it 5 without the absolute value. What did I tell you you have to do? Put a negative in front of it. Every interval that is negative, you have to negate. You're doing absolute value without the bars. Okay? So I would do 1 minus x squared dx. Some kids write x squared minus 1. Same thing. I don't really care. Oh, not -2 to 2. -2 to -1, right? Then, from -1 to 1, I'm just fine. Elizabeth, what do I mean by that? I'm just fine.
There's positive.
It's positive there anyway. So, if I put in a half here, I don't even need the absolute value bars because I'm going to be positive. So, you just don't put them on. Just like that. What else do I need to wrap this one up? The next interval, but it needs to be negated. Exactly. From 1 to 2, 1 minus x squared dx. I wouldn't make you do that by hand. Do you get why? It kind of like a Russian nightmare. So it would say like set up but don't evaluate on a test. So I would be looking for those 3 integrals. All right. Last one up. We're going to skip. We did that earlier in the chapter. We did that this time just now. We're going to go to this very last guy right here. This is a flashback to the first part of 4-5. And I want to make sure you remember, it's been a month, actually. We've been in this chapter a lot, and Christmas was in the middle of it, so that's what you might say, we're not testing for over a week. Yeah, we've got a lot to go back and remember. So the first thing is, this was from your book. It said solve the differential equation. That was the direction, solve it. So we have to make sure we don't just leave it blank because we forgot what it means to solve a dq. A differential equation is when you're given the derivative. It might say dy dx, it might say f prime, it might even say f double prime because that's a differential equation too. Or maybe it even says y prime or dy dx. These are all differentials. What does it mean to solve them? Anyone remember? Usually people forget. That's why I didn't say that. What did you say, Ash? Almost. Y. Yeah, it means what was the original function. If I give you f prime, what was f? If I give you y prime, what was y? If I give you dy dx, what was y? If I give you f double prime, what was f? Do you remember doing these? Do you remember when I gave you f double prime, what did you have to do? Integrate to get to f prime. Fine, Carl. Integrate to get to f. Find the f. Remember? So that's what this is. I need to figure out what y is. This is actually y prime or f prime if you don't like the dy dx. Really, you just need to know to get started what do I need to do? Integrate. If you don't know that, you leave it blank, and that's sad because it's actually not a real hard one to integrate. All right, so I need to integrate, and I like to put constants out front, so I'm going to throw that 18 out there. This isn't today's stuff. What else about this is like, this isn't today's? Take a look at my integral and tell me why this isn't today's stuff. There's no what? No limits. My answer's not a number, it's not the area of the curve. My answer's a function. Whose derivative is that? Kind of weird, right? How do I do that? Only 2 ways. Power rule, you could do this. If Madison's like, I think I'll just FOIL this out and dump the x squared in. It's fine. I don't like that though. What method would I prefer? But it'd be right. It'd be a good thought. But this would be u sub, right? Because the minute this goes like 12, like if Brad wants to do that, he'll be here a while, right? If I change this to a 12 and you want to FOIL it all out, yikes. So we're going to let u equal to x cubed plus 1. Why is there no limit change? Because there's no limits. No, she's right at that, Shelby. See? She even apologized. That's Shelby Novotny saying that. Yeah. Novotny. Right? Novotny. Whatever. These guys have almost the same last names. Put the headset on. Oh no. Alright, I'm covering it up. Alright. Get through. I'm almost done. I'm getting squirrely. I got squirrely third hour big time. I so good second hour. Should have recorded second. What was I doing? Oh, I asked you, I said, why is there no limit change? And the answer is, well, actually, Shelby asked me that. Why don't we change the limits? Because there aren't any, dummy. Anyway, so I do what we normally. Okay, all right, let's go. I can make it. I got this. I got this. I do. It's always when I have the stupid headset on, too. All right. So what's du dx? 6x squared, right? I don't want to keep that dx on the bottom, so remember that's why we go like this. And I ask myself the same question as I want. It's like almost, Shelby, but not quite. It's 1/6 du that I need to replace that with. I sometimes call this a helper box. Do you have to make it? I highly suggest you. All right, next up, what do? I go to u. I go 18. I go integral of, was it squared? U squared? Yep. U squared, 1/6 du. Yay. Now what? What it means? Integrate, antiderivate, whatever you want to call it. 18 over 6 has always been a 3, and it is today. And this would be u cubed over 3, right? And we'll cancel those off, but this was an indefinite integral, so it requires 2 more things. Must have a Carl because it's a function, and I'm getting a whole family of functions, and now you're going to be tempted to leave it because we did definite use of. And we changed limits. But this problem wasn't about u. It was about what? X. My derivative had x's in it. My function better have x's in it. So I do need to back up. Anytime you have that indefinite integral, it was 2x cubed plus 1, is that right? 2x cubed plus 1, quantity cubed plus Carl. This right here represents a whole family of functions whose derivative is that. Am I done? Look at the graph. Did it give me a whole family of functions? There's just one sitting there. Do you remember how I force this guy to be the one of all of them that look like this to be that one? What did you say, Joe? Yeah, let's look at, we need a point. Usually you're given one, but this one a graph was given instead. But usually you need that, we call that an initial condition sometimes. But I know that when I put 0 into the function, that my specific one has to sail through 0, 4. So it looks like Carl today is going to be a 2q plus 1, 1. It's going to have to be a 3 if I do it in my head, right? So my final answer, the specific solution or general solution, some books call it, would be this. Done. That's a review, but it's good to review. Guess why? We're done with chapter 4. Sorry.